Okay, thank you. Hi, my name is Sam Macbeth. I work for a company called Clicks. We build a web search engine and a browser fork of Firefox. I usually work on privacy, but I'm going to talk about something else today, and that is DAT protocol in the browser. So this is something we've been experimenting with on the side. What can the browser bring to empower users? And we're quite inspired by the Beaker browser, which is an Electron-based browser that put the DAT protocol inside it. So this is kind of a story of the process of trying to get this idea. So put a DWeb protocol inside Firefox. So firstly, why do we actually want to put DWeb protocols in the browser? So why is DWeb good for the web? I'm going to give a few examples. There are many, but a few that are relevant for DAT. So the first kind of biggest thing is that you get rid of servers. So in the case of DAT, I can just say, type in the command line, DAT share some folder, and then it's going to give me a link, and I can give that to someone else and they can load my web page. This is really powerful, and if we integrate that in the browser, you could just have a button to create a website, and you don't need to have any infrastructure, any servers, no man in the middle, you have a website. Secondly, it's offline by default, which is really handy. So if I've loaded a website, I can reload it without internet. This is super useful. And now the web has lots of mechanisms to try to achieve this. So bring it back on top of the normal web stack with service workers and all this. But this is really complicated. The DWeb just does this by default. It's also super transparent. So we're familiar with view source on the web. You can look at all the front-end code. But if there's no servers, there is no back-end code that you usually can't see. It actually all has to be inside the front-end source code. So you can view source of the server as well. It's also self-archiving. So if you take a DAT example, there's this API called Data Archive. And I can open some address, and I can just look at the history of edits to that page. And also I can request a specific version. So you can have proper permalinks which are permanent, because they are to a fixed version that will not change. So quick intro on what DAT is. So DAT is a protocol that was developed a few years ago, firstly with the intention of aiding data sharing in academia between research groups. And as I mentioned, the Beaker browser kind of gave it a bit more attention for the web use case with their browser a couple of years ago. We can describe it as basically a file-based single-writer data synchronization protocol. So there's a CLI you can install with npm, and then just type DAT share some folder. This gives you an address on the network, and then on any other computer in the world, I can just write this, and it's going to pull the data directly off me. Underneath, there's two main components of the DAT stack. There's data structure, which is in the hyperdrive module, and peer discovery in Discovery Swarm. So what is hyperdrive? This is a file-like abstraction on top of append-only logs. So underneath you have these append-only logs, which gives you the verification that only one person can write this data. And the file-like abstraction is a good high-level way of organizing the data. So the way this works is I can so the top snippet, I just create a drive on top of some storage. And then I can use simple file commands like write file. But this drive also has a key, which is this address of the data. And then this magic method called replicate. So I call this method, it's going to give me a stream. Now what I can do is on a different device, I can create a new hyperdrive and use this key that the first one that was generated in the first hyperdrive. And now what I just need to do is get this other stream. So this could be over a socket or any other kind of way of piping data between two devices. And I pipe these two replication streams together, and now my data is replicated. So I can now make API calls on my hyperdrive and retrieve this data from the other peer. Discovery Swarm is for connecting to peers for a topic. So I have a swarm, and I just give some topic name. It doesn't matter what. And then it's just going to give me events with connections to other peers. Very simple. Behind the scenes, this works on a few different things like DHT and MDNS discovery. So we just put these two things together. So we just put these things together. So what the hyperdrive has is what's called a discovery key, which is a key derived from the actual address key. This means that your actual address is hidden from the network. So I join, and then I will get a connection from another peer. And then I do this replication piping. OK, so moving to how to implement DAT in Firefox. So what we're aiming for is basically that you can have in the URL bar, just put an address in that is a DAT address, and the browser is going to load it like a web page. So there's kind of two requirements that come out of this. First, we want to actually run the DAT network code in the browser. This at the moment is all implemented in Node.js. And secondly, we want to make the browser understand that DAT is a protocol that should be handled by this bit of code that we're running with the DAT network. So firstly, you think, where do I implement something like that in a browser like Firefox? So first option, we might say native code. This is obviously where the HTTP, HTTPS implementations are at the moment, which would be possible. But there's a few challenges there. So firstly, the native code in Firefox is very complicated. It is extremely high velocity project. And we have to interface with Node.js anyway, which would be tricky to link up with the existing C++. So at least for the first step for prototyping this is not a good approach. So secondly, we could do a web extension. So web extensions are standardized APIs for extending browser functionality. So this is the first attempt. Project is called DATFox. Was DAT in a web extension. And the reason I think this is possible is because there's this API in web extension where you can declare a protocol handler. And they also, Mozilla whitelisted these dweb protocols, so you can have a protocol called DAT, and you can register it. And this is how you declare it in your manifest file. But you can see the problem here. So the last thing we have here is a URI template. This is basically specifying where to go if I get a DAT URL, where to redirect it to. So this is just a protocol switch. It's not a protocol handler. And because I can only switch to HTTP, and I cannot run a HTTP server inside the browser extension, I cannot actually serve this request content from the browser. So even if I could do the first requirement of running DAT in the extension, I cannot link it up with the protocol. Despite that, there is an extension you can install for Firefox. But what it does is it requires you to install a secondary executable, a Node.js process, which will then do the DAT part. So we do some tricks with proxying so that when this initial redirect happens, the extension picks it up and routes it via this helper process to load data from the DAT network. And the image doesn't work. But this works OK. But there are a few issues here. So the DAT protocol is not displayed in the URL bar. It says HTTP. It's also a bit cumbersome to install because you have to download this extra process, and some manifests have to be set to link these things together. Also, there's some quirks with this protocol implementation because it's not designed for this use case. So it only works on top-level loads. If I have an absolute URL for an image or something, it's not going to load properly. So is there something else we can do to get a better integration? Well, actually there is. So in Firefox, there's these so-called experimental APIs, which are the way you implement a new web extension API. And about a year and a half ago, there's some Mozillians who came up with this project called libdweb. And this were experimental API implementations designed to aid or help people build build dweb applications or dweb extensions. And this has implementations for protocol handlers, TCP sockets, UDP sockets, and so on. So what this looks like, for example, for protocol handler, I can just write this in my extension code, register a protocol, and directly have a handler there. So this is exactly what we need. Likewise, I can just create TCP sockets and send data across. So now we have all of the kind of fundamental requirements to do what we want to do, which is run everything inside the extension. But there's still some dots to be joined, because so in the discovery swarm module, somewhere deep in the dependency tree, we just have some module that does require net or require dgram. So they just expect these Node.js APIs to be there. So we have to make that link to kind of give an alternative implementation so it can use that instead. So this is a library called libdwebify that I put together, but this was helped a lot by contributions in the community because people came up with a shim implementation of net and dgram on top of these libdweb APIs. And we can put that all together into a Browserify plugin. So what Browserify usually does is sees these core node libraries and replaces them with shims, and things like net would just have an empty shim. What this does is it, instead of replacing it with the empty shim, uses these new ones to give this extra functionality on top of these APIs. So yeah, this is an extension called DAT WebExt, which does this. So it loads DAT web pages, and it has the protocol correct and is loading everything internally in the browser. So now DAT, instead of running on V8 inside Node.js, it's running on SpiderMonkey inside Firefox. So yeah, so now we have native-like protocol support, and we run the full stack. There's also some other nice benefits that actually this data is in the user profile directory, so we're not just storing in some random other place. Keeps people's data separate. We also found that the new Android WebView implementation based on Gecko called Gecko View, you can also run this in that, and then you have support on mobile. But there's one main disadvantage, is that for these experimental APIs, you need privileged context. So you need to be signed specially to say you're allowed to use APIs. This means that this cannot be offered on the add-on store. It has to be bundled with a browser. But luckily, as I mentioned at the start, I work for a company who does build a browser. So we're currently offering this in beta, but soon to be on release of the Clix browser. And also an upcoming new version of the Android browser will have this in as well. So I'll do a quick demo. So if you've noticed that I'm running these slides in the browser on a DAT page, if you have a DAT browser or just have the CLI, you can just download this and see what's happening at the same time. But yeah, so this is the web, so I can I can inspect, and I can run commands in the page. So I mentioned at the top this DAT archive API that was created in Beaker Browser as a way of allowing sites to modify themselves, essentially, using DAT commands. So we can all do that. We can also do that here. Is that big enough? So I can create this DAT archive for this current page that I'm on. And I can get some info about the current site that I'm loading. And you see there's some metadata about the site. So it has this address. So this is the actual address of the DAT site I'm on. This is the amount of data for the whole thing. And then what's important is this thing. So this is owner is true. This means that on this device, I have the private key for this DAT archive, which means I can write it. So as I can write it, I can just call write file and write a new file in. So now if I go to a new page, well, so this file I just wrote, but I can also delete it, obviously. And now if I refresh, it's gone. And if you were syncing, you would be able to get these changes in real time from my device. Yeah, and also we have history, of course. So you can see a list of all the edits I've made to this page. So you see I tested out the demo a few times beforehand. But then I can show that we have this idea of versioned URLs as well. So at this version, this file doesn't exist anymore. But it existed in a previous version. So I can just put the version number in the URL. Or which version was it? OK, so at version 38, this file existed. So now this is a permanent link to this version of this file, which will never change. OK. All right, so what are the next steps? So we've got reasonable support so far, but there are a few challenges coming up. So the first major thing is we want to try to upstream libdweb because it's outside Firefox core, but the implementations of the experimental APIs use internal Firefox APIs, which are constantly changing. So this is quite a maintenance burden to keep having to fix this with every other Firefox version. So take one example, this service discovery implementation in libdweb. The internal class it used was just removed from Firefox a couple of versions ago because there was no test that says we need to keep this. So they thought, oh, I'll just clean out this old stuff. So now there's a ticket to bring it back, but this is the kind of thing we can avoid by upstreaming this into Mozilla Central, so that they will have tests for this, and these APIs will keep working. There's also some improvements to do in the protocol handler integration. So because the browser is not so, this implementation is kind of a bit of a hack, and it mostly works for most parts of HTML and JavaScript, but the browser doesn't understand it necessarily as a HTTP page, and certain elements break and certain storages break. So that's something that needs to be fixed. Also, we don't have control over other parts of the experience. So this info bar, so the one next to the URL, which is meant to show you some information about the page, we're not yet able to add information there to explain what this is, what this protocol is. Also, so far, the DAT network has not been tested at scale. This is something we'd like to do to see how this discovery mechanism scales up if you get several orders of magnitude more users on a DAT site. And also to test different network environments, so lots of users will be are we behind different types of NATs, and whether they can always escape that and make connections to other peers. There's also DAT version 2, so a new version of the protocol is coming up soon, and there's some extra challenges on getting that to work in this context, largely because of new crypto that it's trying to use, which doesn't have an implementation for the web yet. And yeah, then we want to build more things on DAT, so more applications that users can use to publish sites or upload things and send them to their friends. Obviously, it goes without saying that all of this stuff is open source, so these are just a load of links to different projects here, so DAT project stuff, Hyperdrive, libdweb, and these extension implementations at the bottom. It didn't all fit on the slides. There's another one, which is the browser, but yeah. So thank you. Any questions?
We have 5 minutes for questions, so almost 5.
Hello, thank you for your talk. So currently, Beaker browser experiences many extensions to the Unwalled Garden project with many more features.
Sorry, I can't quite.
The Beaker browser gets many more extensions regarding the Unwalled Garden project to this. Will you try to implement this as well?
Yeah, we'll have to see. I'm kind of waiting for when the finalized version of that comes out. Ideally, this would work in user land, so we just provide the base support, but we'll see. Also considering exposing kind of an API so other extensions can also talk to this extension to do kind of peer-to-peer stuff as well. So expose some of the lower level APIs for building applications for that.
So I wanted to ask, what's the main difference between DAT and IPFS?
The main difference?
Yeah, any difference? Because I don't see really what's the difference basically.
Okay, so one main difference with DAT is that it's scoped to a particular address. So I'd make one hyperdrive, I have this address. And this is a separate individual swarm, so I'll only ever talk to people for that address. IPFS is going for a more global network. So you put any file in IPFS and you talk to everyone in the whole network to tell people that this file is here. DAT is also not content addressed, so you just have a key pair as an address and then you put data into that folder. IPFS content addresses everything. So in IPFS, when you put a file in, the address for that file is based on what's in the file, and this is then immutable, so that address is always that file. But DAT has this mutability on top because it's not tied to content addressing.
Okay. So I missed 1 minute of your talk, so sorry if you've covered it in that 1 minute. But my question is, I know there's a JavaScript implementation of DAT.
Yes.
Yes. Does but it's marked as unsupported. How unsupported is it?
The old one. So there's a few different approaches in the DAT ecosystem to the web. So Hyperdrive itself is agnostic of how you find and talk to other peers, and this has always been browser fiable, so you can always put that in browser. Because the networking, the discovery swarm part is tied to being able to open TCP sockets, obviously that doesn't work in the browser. So then there's a few different ways you can get around this. The DAT.js was using WebRTC to talk to, but then the problem with that is it's an incompatible network. So you have like one swarm which is DAT in the browser people, and then another swarm which is DAT node people, and they couldn't talk to each other. So then there's a few other approaches. You can, for example, open a WebSocket to a gateway and synchronize data with them, and they can bridge to the rest of the network. There's also other ones that act as just other types of gateway which just act as discovery gateway. So you just stream to this, and it will find other peers, and then proxy those streams. So actually that gateway doesn't know anything about what you're looking at. What we're doing now in this is doing a combined approach. So because we can do the normal networking, but we can put WebRTC alongside it to help with discovery, because sometimes it doesn't work over sockets.
Okay, thank you very much. We do not have any more time for questions. Thank you again for giving this talk.